Good morning, one and all present here. I am Nandini D, working as an assistant professor in SNS College of Technology, the Department of Computer Science and Technology. Today, we are going to see a topic of Gaussian Mixture Model. So, first, we are going to see the overview of that. It is defined with an probabilistic model, which is representing the mixture of Gaussian normal distribution for each Gaussian distribution. So, it is mentioned with the help of mean, covariant, and weight. So, mean is defined with center of each Gaussian. Covariant means shape of each Gaussian. Weight means importance of each Gaussian components. So, next is what is the algorithm or working condition of this? There are some three steps used in this. In this EM algorithm, GMM, Gaussian Mixture Model has three steps. One is initialization, E step stands for expectation, and M step stands for maximization. So according to that, we are going to see it. Next is objective. This EM algorithm in essential parameters of probabilistic models. It consists of expectation and maximization steps. So this Gaussian Mixture Model has a soft clustering algorithm. So now we are going to see an goal of an empathy phase. In it, we should understand the problem and user needs so that before building an Gaussian mixture model, we should find how we are understanding the data and the problem. Then we are asked to question like what type of data do you have? Why do we need that clustering type? Or these hidden groups in the data are equal? These questions have been asked. Next that for example, in customer segmentation, a company wants to identify the different types of customers. So based on their purchasing behavior, we should understand the user needs, how they help us decide whether the GMM is the right solution. This is the goal of this MP. Next, we are going for the phase of define phase. So in the define phase, we are going to apply a real world overlapping clustering hiding models so that how effectively this approach is working, how they improve this clustering activities. This consists of k-means, Gaussian mixture models, how correct the cluster is, how wrong the cluster is. In this, we are going to see a goal that clearly defines the problem. Now we are defining the problem. The challenges is to group similar data points when we don't know the category beforehand. The traditional method like k-means assures clusters are spherical, but real-world data often has overlapping clusters. This Gaussian mixture model solves this by assuming that the data is generated from multiple Gaussian distribution. Our objective is to identify these hidden distribution and classify the data accurately. So next of all, we are going to see an ideate phase. In this ideate phase, we should know first how this model clustering probabilistically used without overlapping or with overlapping membership. This estimate membership probability have each data point to handle the uncertainty. Then identity redefine the parameter to maximize this clustering growth. The goal in this iterate phase is generate a possible solution. At this stage, we explore different clustering methods such as k-means, hierarchical clustering, Gaussian mixture model. We choose this GMM because it provides a soft clustering, meaning each data point has a probabilistic of belonging to each cluster instead of being assigned to only one. This makes GMM more flexible and accurate for complex data sets. This is a prototype phase. In this prototype phase, we should explain the diagram first with an initialization, next expectation, maximization, and conditional checking. How that working. In this phase, the goal is to build the solution. We implement the Gaussian mixture model using a machine learning libraries such as Kit learning. We pre-process the data. We select the number of Gaussian components, train the model using expectation and maximization algorithm, and assign the probabilistic to each other data point. The output is a cluster data set where each point belongs to the most probabilistic Gaussian mixture. Next phase is an test phase. In this, the goal is to evaluate and improve the model. Finally, we test the model by checking whether the clusters are meaningful and useful. We compare the result with other clustering methods, evaluate the matrices such as log likelihood, AIC, and visual the clusters. If the performance is not satisfactory, we adjust the number of Gaussian components before the data is given. This Iterative testing helps improve the accuracy of the Gaussian mixture model. So we are conducting some activities and a mind map is shown. Thank you so much, students.